Hello, let's talk about MugatuWare for a little while. So that was 10th challenge from Flare on 2019 competition. And yeah, it's been a while since my last video about Flare on. And that was due to that Mugatu was one of the hardest challenge for me from 2019. Of course, apart from the challenge number 12, which I didn't do due to the limited time. But yeah, I spent a lot of time investigating Mugatu, and yeah, finally I did manage to solve it, but there's, I guess, quite a lot of stuff that I still don't understand. So I hope I will give enough information how it could be solved, so you will learn something from this video. And I would like to thank Megabits, who give me a push to try a little bit harder with this challenge, and thanks to him I managed to solve it, eventually. Okay, so let's start with the message. The message is quite lengthy in this challenge, and yeah, if we read it, we get information that, okay, Derek Zoolander clicked a link and the files were encrypted, and that was a GIF or GIF file, however you spell it. And we get information what actually we get in the package. So we get the malware sample, we get the ransom note, we get encrypted headshot GIF, best.gif.mugatu, and we have encrypted informant GIF. The key to success, 0000.gif.mugatu. Okay, and we can, I guess, approach it from different angles. I started with just running the sample. Of course, in the VM, I didn't know what's actually is doing. Maybe it actually encrypts all the files, so it's safer to just execute in VM. So I have it here, my VM, and if I start Mugatu, so actually we started and nothing really happens. We can see in process hacker that it actually is started, but yeah, we don't see actually nothing on screen. So we can just kill it for now, and we could, oh, that's wrong icon. Okay, so that doesn't give us much. So the other thing we can do, we could try a static analysis, and I have Ghidra here with a sample. So I already analyzed it, but during the analysis we would find out that actually the imports doesn't make sense. So basically the imports are mixed up. Like for example, here it was identified that we have some while loop that waits for some HTTP response, but then in the while it was calling get current process, which actually, well, maybe does make sense, but I would expect something else. And if we would run this sample, and we will see it in a moment, in the debugger, this will be a sleep function here. So if we just statically analyze this malware, we'll not get much information, but still we'll get some information like this wait for HTTP, which we could analyze, that basically we can get some information like it tries to connect to this mugatu.flareon.com, and it will send a request to that address. So what we can do to find out if it actually gives us something, we can just create a simple, that's from another challenge, we can create a simple Python script that actually will act as a server. We could actually use some one-liners, but I thought maybe we'll have to send some data, so I just went through a little bit more and create a simple HTTP request handler, which will do get and post. And in the post, actually I was sending this GIF, maybe thought that it will decrypt the file, but unfortunately it didn't worked. So we are just hosting it on localhost port 80, and what else we need to do, of course, is to add this address that we saw in the in the binary, we need to add it to our hosts file. So basically we can use this name and it will redirect to localhost. And with that, and after we start this server, okay, and now if we run the sample, something else will happen. Now we'll get some pictures from Zoolander, I guess Zoolander 2. Yeah, I'm not a big fan of the movie, so yeah, it's probably those. But yeah, so actually in the beginning I thought maybe this part somehow is a flag. Maybe we need to somehow make sure that those images show up correctly. So I spent some time trying to investigate if there is anything remotely connected to making those pixels readable, I guess, because they look like they were intentionally destroyed. But yeah, that doesn't give anywhere. So I was stuck for a little while, but actually during the static analysis there was few places that were quite interesting, because this waiting for the request and showing the pictures, actually it was interesting because just after that there was actually some dynamic code execution here. So Ghidra showed us, okay, something is going on here. You could see that it's actually checking some exe file constants like this here, mz. We could change it to ASCII and it's mz. So it's something with exe file being checked, and then it was executed, some code here. So actually, if we would do that code in the debugger, I will try to now find this part. Hopefully I can manage. So we have our sample here. We'll just go to the user code, and I should have some breakpoints set here. Okay, I probably have not enough breakpoints as I thought. But let's see, let's go to this one, because we could see there that, okay, we do some virtual alloc, virtual protect, and we were writing something to this unprotected region, and then we were calling this this part of memory. So that got me thinking that, okay, maybe it means that we need to look into that part of the application. And yeah, that works. So when we jumped into that code, I will not just look for it right now. I have it dumped also in Ghidra. So again, the imports were not correct here. So there was like something strange with the import, so it was showing completely different method that it's supposed to show, but with some manual pre-processing of this file, I actually managed to find out a little bit of it. So basically it was DLL, so we got the DLL main function, and from that we could work our way through the function, but it was actually huge file, and I think I dumped like the whole DLL with a lot of statically, I guess, imported function, because I was analyzing some function that in the end it was like memcopy or something like that. So I spent a lot of time doing that, and I guess that was the one of my problems, that it took so much time to actually find the flag. But nonetheless, both doing static analysis and running in the debugger, I managed to find the crypt function. And it was actually quite interesting because there was some kind of XORing involved and bit shifting, so that got my attention. And also it was like, okay, we are reading the file, reading the data, and passing to this function. So that was one of the breakthrough. But when I saw this algorithm, I have no idea what it is at the time. Yeah, because I haven't actually seen that one before this Mugatu. Actually, after that I seen it already next in one of the video I recorded previously, and that was the core dump. But in the other one, this constant was changed. But this constant was actually, yeah, key to finding this algorithm, because we can see it's some kind of magic constant that is used in this algorithm. And if it would be changed, it would be maybe a bit more harder to find out what was the algorithm. But with this constant, we can find that this algorithm is this XT algorithm. Yeah, we have the constants here. Let me see if it's actually the same. Yeah, it looks it's the same, and we have the same bit shifting and XORing involved. So we actually managed to find out the algorithm. So that's very good. We could then implement it or use some kind of library to emulate and try to see if we if we can decrypt those files. But we didn't know the key that was used to encrypt those files. And here where the two files are helpful. So if we could read in the message, we got the encrypted informant GIF, which was this key to success 0000.gif.mugatu, and this encrypted headshot GIF, which was this one that we probably needed to decrypt. And we know that there were the GIF files, so we know how the GIF format is structured. We know that there is this GIF information in the header, so we could actually try to decrypt only those 3 with additional 4 byte and see if they match. So we don't have to decrypt the whole file, because this is like a block algorithm. So we can decrypt each block and see if it matches, and then if only if it matches, proceed with next blocks. And actually I did that. I don't have this algorithm here, but I have the bits and pieces of it. So I have the ncipher, I don't know why I give it such name, decipher function, and I got this probe method. So basically it will decipher just 4 bytes, so 32 bits, and it will check if it's this GIF 8. It is in this decrypted data, and if it is, then I will say, okay, the probing worked. And then I don't have it here. I'm passing the key. In checking the key, it was just a loop, and I'm doing it for the actual file. But the key to success was that actually the key was all zeros. So this is the data from the key to success file. This is it's encrypted with all zeros, and I'm checking, okay, probe works, so I know that my algorithm worked. And then I will show it in a moment. So let's see actually what's in this, the key to success in this file. What was there? Let's just go to the desktop and flare on 10 Mugatu. And let's see if I have the file. I think that's the file. Okay, yeah, so that's the file that we got from this, the key to success, and it says, what if I told you that the first key byte is 031? So that actually limits the possibilities that we need to run through for the actual file. That's why here, when I'm doing the actual decryption of the file, I'm already using the product only for 3 bytes, because I know that the first one is 31. And again, I'm just giving the those 4 bytes for the probe function to check if the key works, and only if the key works. I know I could just skip this. If the key works, I will decipher the whole file with the found key. So it's actually a bit faster, but anyway, it will still take a lot of time. if I run it now. So let's Python decrypt. Am I in the correct? Okay, so the prop worked. So at least this is the check for me that the function I wrote works. So basically we decrypted those bytes with the keys all zeros, and we got something that is translatable to give 8. So now it's trying to find out the 3 remaining bytes for the key for the actual file. As I said, it will take a while, so it's just print some indicators that it still works every 100,000 times it runs. So we'll wait a little while, but I already have it decrypted, so I can show the file now, and we'll wait for the brute force to finish, so we know it worked. I can close this one. We won't need that. Okay, so let's see the actual flag. So the flag is best give, and it's flare on so hot right now at flare on com. So after we find the key in the with this decrypt function, we were able to decrypt the best.give.mugatu, and that gave us the flag. Yeah, so more or less that was the way I did that. There was a lot of I guess some things that I didn't know whether I should continue investigate them. I can see there are some solution scripts that there was some kind of crypt libraries being used. I tried to do it in Python. There was also some kind of mailbox creation in this Mugatu that I thought maybe if I created the sample will send something to this mailbox or mail slot, but didn't work in the end. So I guess that's why I had so much trouble with it. I guess I'm not that experienced with malware. But okay, let's see if our script work, and it's still searching. Here we could see that when we run, our server got a post request, so we saw that worked also. But as I said, the actually finding is a bit hard. It will take some time, so I guess I will speed up. I hope it will not be one of those cases that, actually it won't work this time. But I think I ran it a couple of times and all the times worked. So let's have our finger crossed. And I guess few more executions. There are many cases to be checked. So actually having this additional information that the first byte is 31 hex actually limits quite a bit. Without that, I guess it will be even harder to find the correct key, unless there is something in the Mugatu that actually gives some info. I don't know. I haven't found anything, but I guess I might have missed something. So maybe there was a way to actually get those bytes quicker, but nonetheless we can get that by brute forcing those 3 characters. I guess in this environment it's not the fastest. I'm in VM, I'm recording a lot of stuff going on, so I guess I could get a few more cycles if I run it in non-virtual environment and get this bytes a bit quicker. But I guess few more executions. I for sure need to speed this part out in the release video, so you don't have to wait as much as I had to wait to show you. But I guess, as I said, yeah, recording might have slowed this even more than from what I tested previously. But yeah, we should get the bytes pretty soon, I hope. I'm just wondering if there's anything I can show you more in this challenge. I think I said about everything, at least everything I got from this one. But yeah, I learned quite a lot. I guess I'm still not understanding fully this challenge, and yeah, it for sure could have been solved more easily than fighting with all the static analysis and debugger. Yeah, with all the tricks that we can see here. But yeah, let's hope to see those magic bytes in a moment. Yay! Okay, finally we got the bytes. So it's yeah, the printing also not very good. It's 31, 73, 35, B1, all hex decimal digits. Yeah, so that was the key, and yeah, it's actually right now it's decrypting the file, because that's how the script works. But yeah, we saw already the flag. So I guess that's all. I hope yeah, you liked it. I hope you learned at least something from this video. I know I learned a lot trying to solve Mugatu, and yeah, thanks again to Megabits for pushing me to try harder with this challenge, and yeah, finally solving it. Yeah, so that's all for today. Bye.